Hello again, it's Mrs. Duodoth here and I'm going to be taking your lesson today. Let's go through the practice activity that I left you last lesson. Did you notice anything about the equations? Can we use our generalisations to help us solve them? If we have a look at 6 plus 1, we know that adding 1 gives 1 more, and 1 more than 6 is 7. And then if we look at the equation next to it, we can see that it's just that the order of the addends has been changed. So we know that when we change the order of the addends, the sum remains the same. So 1 plus 6 is 7. 5 plus 1. 1 more than 5 is 6. And we can see on the opposite equation that we have just changed the order of the addends, but the sum remains the same. And then we've got this one here, 4 plus 1. 1 more than 4 is 5. And there we've just changed the order of the addends in the next equation, so that is also 5. Now 0 plus 1. 1 more than 0 is 1. And 1 plus 0 is also 1. Here's our number line again. This time we're going to start counting backwards, so we're going to start on 10. Do you think you can help me? Are you ready? Here we go. 10, 9, 8. Oh no, there's a number missing. Did you say the right number? What's 1 less than 8? Did you say 7? Fantastic. 6, 5. Oh, I've got another missing number. 1 less than 5. What's 1 less than 5? Did you say 4? Well done. 4 is 1 less than 5. 3, 2, 1, 0. Great counting. We're going to be using this to help us solve some problems today. Do you think you could help me to tell this story today? What can you see in the picture? Pause the video if you need to. So we could say first there were 8 donuts. Ooh. Then what happened? Could you pause the video and tell an adult, or you can tell me what happened next? Then someone took a donut. Someone took 1 away. Now, how many are left? What would the equation look like that goes with this story? Have a think. So we've got 8 donuts first of all. First we had 8. Minus 1 is equal to, wow, I know that 7 is 1 less than 8. So 8 minus 1 must be 7. 8 minus 1 is equal to 7. What does the 8 represent in this equation? That's right, the 8 represents the 8 donuts I had first of all. What does the 1 represent? Yes, the 1 represents the 1 donut that has been taken away. And what does the 7 represent? The 7 represents how many donuts are left now. Did you notice something? I can see that when I subtract 1, the difference is 1 less than the minuend. We could also represent this equation with a bar model. What would go where the question mark is? Did you say 7? That's right, because 8 minus 1 is equal to 7. And remember, when I subtract 1, I can see that the difference is 1 less than the minuend. 7 is 1 less than 8. Can you help me to tell this story? First, there are 5 counters. Then I take 1 away. Now there are, what's the equation that goes with this story? 5 minus 1 is equal to 4. I know that 4 is 1 less than 5. What does the 5 represent in this equation? The 5 represents the 5 counters that I had to start with. What does the 1 represent? The 1 represents the 1 counter that I took away. And what does the 4 represent? That's right, the 4 counters that I have left. And I know that 1 less than 5 is 4. I also can see that when I subtract 1, the difference is 1 less than the minuend. How many pens are in this picture all together? Pause the video if you need to count them. Did you say that there are 7 pens all together? And how many of those pens are orange? That's right, one of the pens is orange. So what would the equation be to find out how many pens are blue? Have a think. Did you say that I would need to do 7 minus 1? 7 minus 1. Well, I know that 1 less than 7 is 6. So I can say that 6 of the pens are blue. What does the 7 represent in this equation? That's right, the 7 represents the 7 pens that we have all together. And what does the 1 represent? Yes, the 1 represents the 1 orange pen. And what does the 6 represent? That's right, the 6 represents the 6 blue pens. I can show this problem using a part-part whole model. What's my missing number though? Did you say 6? That's absolutely right. And can you remember that when I subtract 1, I can see that the difference is 1 less than the minuend. How many counters are there altogether? That's right, there are 5 counters altogether. And how many of the counters are blue? Yes, one of the counters is blue. So what would the equation be to work out how many red counters there are? Did you say that I would need to do 5 minus 1? And what's that equal to? That's right, 1 less than 5 is 4. So 5 minus 1 is equal to 4. What does the 5 represent? Yes, the 5 represents the 5 counters I have all together. And what does the 1 represent? The 1 represents the 1 blue counter. And what does the 4 represent? Yes, the 4 represents the 4 red counters. And I know that when I subtract 1, the difference is 1 less than the minuend. I can also represent this problem using a part-part whole model. What would go in the missing part? That's right, it would be the 4. What does the 4 represent? Yes, the 4 red counters. And what does the 1 represent? the one blue counter. And what does the 5 represent? Yes, the 5 counters all together. So if we know that subtracting 1 gives 1 less, I bet we can answer these questions really quickly. We also know that when we subtract 1, the difference will always be 1 less than the minuend. Shall we see if we can do these together really quickly? I'm going to say the first part of the equation and I would like you to say the difference. Are you ready? 10 minus 1 is equal to 9. 9 minus 1 is equal to 8. 8 minus 1 is equal to 7. Yeah. 5 minus 1 is equal to 4. 4 minus 1 is equal to 3. 3 minus 1 is equal to 2. That's right. I bet you did them really quickly. You're getting really good at this. I want you to have a go at these questions now. Pause the video. You can either just say them or you can write them down if you would like to. But look carefully. Are they all subtraction equations? No, that's right. Some of them are addition. Remember, subtracting 1 gives 1 less and adding 1 gives 1 more. Pause the video now and have a go at these. Did you have a go at them? I bet we can do them really quickly. We're going to say the equation together. Are you ready? 3 plus 1 is 4. 1 plus 9 is 10. 4 plus... Ooh, this one's a bit different. This time one of the addends is missing. 4 plus is equal to 5. Well, I know that 5 is 1 more than 4, so the missing addend must be 1. 4 plus 1 is equal to 5. Oh, let's have a look now. It's the sum that's missing. 1 plus 1. So that must be 2. 2 is equal to 1 plus 1. The sum is missing in the next equation as well. But 1 more than 5 is 6. So 6 is equal to 1 plus 5. Now, I've got my first addend missing. Plus 1 is equal to 8. That must be 7, because 7 plus 1 is equal to 8. Now I'm doing some subtraction. So 9 minus 1, well, I know 1 less than 9 is 8. Oh, this is a bit tricky. 1 minus 1. But 1 less than 1 is 0. Let's have a look at this last one. 7 minus is equal to 6. But I know that 6 is 1 less than 7, so the missing number must be 1. 7 minus 1 is equal to 6. You've worked really hard today and you're getting really good at this. I want you to have a go at these 2 word problems now. I want you to think about what equations would go with each question. There might be more than one equation. And can you draw a bar model or a part-part-whole model to go with this? So question 1 says, I find 1 conker in the playground. I pick up 6 more on the way home. How many do I have now? Can you write the equations that go with that question and draw a bar model or part-part-whole? Then question 2. I challenge myself to swim 4 widths of the pool. I have swum 1 width. How many more widths do I need to swim? Again, can you write the equations that go with this problem, and can you draw a bar model or a part-part-whole model to go with it? Well done for all your hard work this time.